Welcome once again to Theme Park by GPD, and this time we are looking at the June edition. The focus is on facade engineering, and we do have here a very interesting presentation from Glas. Nice to see you again. Kindly start by introducing yourself.
Hello together. My name is Bruno Kassnel-Henneberg, and I'm head of the Structural Glass Center from Glas Trösch in Switzerland. With my team, we are responsible for special projects and special product development. I work with Glas Trösch since 2012. As a member of the SIA Standards Committee for Glass Construction in Switzerland, we have established a first design code for glass in 2021. Before my time with Glas Trösch, I was head of the structural engineering team at Isolier. By profession, I'm a structural engineer and I studied at the University of Stuttgart.
What about your topic this time? What are you going to be telling, or what are you going to be talking about?
First of all, I want to say many thanks for the possibility to be part of the Theme Park this week with the topic Facade Engineering. In the paper, New Products with Structural Silicon Bonding, I wanted to give an input to people who are interested in new ways of silicon design which might be used in future products or projects. The complete new approach of silicon design we use was developed by the University of Darmstadt within the doctor thesis from Michael Glas at the Institute from Professor Jens Schneider. As this completely new material law provides the opportunity to do any kind of geometry using structural silicon bonding, this design method opens a wide range of new applications. We can go far beyond the current geometry restrictions limited by the ETAC 002. It is possible to prove that high loads can be transferred safely using free-shaped structural silicon connections. The analysis approach using the Nelder-Truss material law predicts safely the real load carriage behavior and determines precisely the critical areas of a freely chosen bonding geometry. In addition to the material law provided by Michael Glas, we have not only specified the required material parameters to use the Nelder-Truss material law, but we also have developed a design concept which is generally accepted by the German Building Authority in Berlin within the framework of the application of our fully bonded glass balustrade system, Swiss Railing Flat. More information will be given within the next few minutes, but of course also in the paper and on the huddle on the 16th of June. Hope to see you there.
What is the fundamental difference between the existing silicon design according to ETAG 002 and the new procedure with the Nelder-Truss material model?
ETAC 002 only allows a very limited joint geometry. The height to width ratio is limited to 1:3. With the Nelder-Truss material model, it is possible to accurately calculate any adhesive geometry.
What is the Nelder-Truss material model for structural silicon adhesives all about?
It is about a material model for silicon which enables correct calculation results for any geometries. Especially in the area of hydrostatic stress conditions, this material model differs fundamentally from all other previously known models for silicone.
And finally, what is a hydrostatic stress state?
Hydrostatic stress state means that, for example, an imaginary material cube that has been cut out is under pressure or tensile stress from all side surfaces. In visual terms, this means that the shape of the cube does not change under load. These stress conditions occur more strongly the further the joint geometry deviates from the 1:3 joint ratio defined in ETAC 002. Up to this ratio, it can be assumed in a good approximation that the joint can change its shape under tensile load, and thus practically no hydrostatic stress stage occur.
Bruno, thanks a lot for this very interesting introduction. Definitely, I'm looking forward to further discuss this issue on Thursday this week. Have a good time. See you soon.